in Japan, your MC for this session. Learning something new often feels like walking through fog, uncertain, frustrating, but full of possibility. For Loredana Horezeanu, that fog was Python. Less than a year ago, she began exploring how to turn raw data into interactive dashboards, not just to practice coding, but to tell stories that matter. Stories about Earth, climate, and children's lives. In this session, she will share her journey of moving from confusion to clarity, from first steps to a working dashboard, and how embracing imperfection can light the way forward. Let's welcome Loredana H. From Fog to Lighthouse, a beginner's journey from raw data to a functional dashboard.
Remember those painful 3 a.m. debugging marathons, soaked in caffeine, and your patience wearing thin by the hour? When every little tweak to your Plotly code would result in an error, far too cryptic to understand. And against your best judgment, you would still hit refresh, hoping that this time around your code will flawlessly execute. It didn't. But you kept pushing, and then there were those micro moments of victory when merging finally worked, and those spaghetti-like data rows seamlessly aligned, and your map finally rendered on your screen cleanly and effortlessly after you tinkered with a geometry variable for what seemed to be an eternity. My talk today is for anyone who has stared at raw chaotic data and wondered, how I'm going to turn this mess into clarity. Hello, everyone, and welcome to the 2025 PyLadies Global Conference. My name is Loredana, and I'm going to share with you highlights from a journey that I named quite poetically From Fog to Lighthouse. How to turn raw, messy data into a functional dashboard using Python's Pandas, Plotly, and Dash. My main objective has been to leverage Python's ecosystem to process raw messy malaria survey datasets and build a dashboard to visualize malaria risk in children under 5 in Nigeria. Of course, using Plotly and Dash. The data sources I used were the malaria surveys for Nigeria for 3 years, cluster GPS coordinates to merge the cluster locations into the data, and the shapefile for Nigeria, which allowed me to construct the map. The key variables was malaria prevalence. Malaria was tested through the rapid diagnostic test and the blood smear test. If the child tested positive for either of these two methods, it was marked as positive. I also used anemia, sanitation, mother's education, and wealth. And I computed this. So the initial analysis was at the child level. I then computed indicators at state and cluster levels for the dashboard using sampling weights, which allowed me to obtain results that were nationally representative. The datasets I used for this project were household for the sanitation and wealth information, the mother-child dataset that gave me the variable on mother's education and the biomarkers for like anemia and malaria. I encountered countless challenges in processing the data, including misaligned identifiers, merging shapefile with the main data file, constructing wash indicators, and a lot more. One of the more serious issues I was faced with while processing the data were the misaligned identifiers, which prevented the correct merging between datasets. It also took me quite some time to figure this one out, just because it was not something very noticeable at first sight. And I had to step away from everything what I was doing and spend quite a lot of time with the data trying to understand what's going on. In the end, I found out that children, and I'm refer here to the tested children in the data set, were counted and identified differently between different data sets. And once I figured that one out, the merging happened seamlessly. So the lesson here is to step away from coding, eyeball variables, and try to understand the inner logic of your data. Now I'm going to share with you a brief demo of the final product, the dashboard I built using Plotly and Dash. It has a year drop-down menu, the 3 years of the surveys that I worked with. It also has a wash level slider with 3 categories from low to high. Low means no access to either improved drinking water or sanitation, and high means full access. Both 2 panels, on the left-hand side, a map at the state level showing the malaria prevalence. And on the right-hand side, there is a scatter plot showing the relationship between malaria and anemia at the cluster level under different wash level conditions. When the user selects any given state from the drop-down menu, both panels react or update dynamically in response to that selection. As we can see, also for 2010, okay, going back to 2021, we notice, for example, in the map, the northern states in Nigeria show a relatively high malaria prevalence, exceeding 60%. Kebbi, Zamfara, Yobe, these are states that also in year 2010 and 2015 have a fairly high malaria prevalence. Moving on to the right-hand side and to the scatter plot, we notice in the legend that the bubble sizes are defined by mother schooling in years, from no schooling to 13 plus years of education. So the more educated, then the higher or the bigger the bubbles are. Moving to a medium wash level, we notice that for some clusters, they shoot up for malaria, but the anemia prevalence stays modest, which tells us that malaria prevalence in children under 5 in Nigeria is not necessarily explained by anemia alone. Although, as we can see, the clusters with lower mother education, they do tend to have a higher malaria prevalence under medium wash conditions. As we move towards high wash access, something shifts in this chart. So the clusters drift downward. High wash access seems to be generally associated with lower malaria transmission. Anemia, however, remains unruly, even at the lower poverty and with better educated mothers. This is just a glimpse of what this dashboard begins to reveal as soon as we zoom in, and with every interactive feature selected, more layers of Nigeria's public health story come to light. Let me now explain how I built the scatter plot on the right-hand side of the dashboard, both the reasoning behind it and the structure of the code that actually makes it work. So I will start with the first code snippet, which is about filtering data and conducting some necessary checks. Before anything appears on the chart, I just want to make sure that the data is clean, complete, and filtered correctly. So I begin by making a copy of the cluster level dataset and also check whether it's empty. If it is, the code will stop running and the user is warned. Then I move to the panel controls, the year and the wash level. Once I know which year the user selects, I filter the dataset down to only that one year. I will only show one year at a time, the selected year. I apply the same idea to wash categories on the slider from low to high. Finally, I check that my key variables without which the dashboard cannot exist, anemia, malaria, wealth category, and mother's education or schooling in years. If any of these columns are missing, or if filtering leaves the data set empty, I'll basically exit and the code will just stop running. Moving to the next snippet, my goal here is to turn raw survey numbers into something meaningful, something intuitive, and of course visual, something you can figure out at a glance. I wanted the bubbles to grow proportionally with mother's education in years, so I converted this variable into clear categories, starting with no schooling and then 1 to 4 years of education and so on. Each category is mapped to a bubble size. Bubbles start ballooning as the years of schooling go up. So I believe the audience can intuitively grasp the direction of the bubble scale just by looking at the chart. I then move on to the poor versus non-poor category because wealth is, well, a critical determinant for health. I clean and standardize the variable because I do not want ugly surprises later. So I want this variable to behave as I expect it to in the form of poor versus non-poor. I also color the bubbles based on this variable in the scatter plot. So to conclude, in this snippet, shapes and colors tell vivid stories in the dashboard. Moving on to code snippet number 3. In the third snippet, I built, so the third snippet has two parts, so I will just discuss them both. Here I build the actual scatter plot and the legend. Plotly works by adding layers or traces and stacks them. It can't create grouped legend sections on its own, so I build the legend manually using invisible layers. I also had to fake some layers in the legend because of that. So I created some artificial elements, each showing the bubble size for one schooling category. So none of this actually do show up on the scatter plot, but they make a very clean, readable legend. I then add the real scatter data. I loop through the two wealth categories, non-poor and versus poor, and for each group, I filter the data set and plot the bubbles on the chart. Anemia on the x-axis, malaria on the y-axis, bubble size for mother's education, and color for wealth. These are the actual points that the audience can see on the scatter plot. And finally, the last snippet is for polishing the chart, adding some color, adjusting margins, making titles easy to read and fonts consistent. This final snippet ensures that the chart will stay aligned with the overall aesthetic of the dashboard. That's it from me for today. I hope you enjoyed peeking into my journey from fog to Lighthouse. And if there is one thing I hope you'll take away from this talk today, it is this. Keep going through that fog because clarity will come to you gradually in tiny steps. And by the way, don't be fooled because Plotly will definitely test your endurance. Dash callbacks will misbehave constantly. And yet, every fixed bug and every chart rendered beautifully on your screen will take you one step closer to that lighthouse. Thank you all for being part of my story today.
Awesome. So dashboards are not just about charts and code. They're about turning data into stories that shine a light on issues that matter. Uh, Loredana's journey showed the value of persistence, of learning through trial and error, and of finding beauty in projects that are still evolving. A huge thank you to Loredana for this amazing presentation, and thank you all for being part of PyLadies Con 2025.